Okay, today we are going to talk about our second way to solve a system. Yesterday, we learned how to solve a system using graphing. Today, we are going to look at the second way, which is solving a system by substitution. So remember yesterday, when we found our solution, we recognized that a solution was an ordered pair that makes both equations true. Okay, that is a solution to a system of equations. Now, keep in mind, yesterday we also looked at a couple of examples of a system that did not have any solutions, or a system that had an infinite number of solutions. So today, the method that we're going to learn is the substitution method. The substitution method can be used when you have more than one equation with the same variables. And the equations that we're going to be working with are linear equations, which just means that both the x and the y variables have an exponent of 1. This is just an example of a system, y equals 2x plus 3 and y equals x plus 5. So the basic idea of the substitution method is that we are going to replace one variable with an equivalent expression containing the other variable. Keep in mind, at any time during the video, if you need to pause it to make sure that you get everything written down, you can. All right, so here's our first example. We're going to solve the system using substitution, and our system is y equals 2x and 7x minus y equals 15. The first thing that I like to do is write the equations out side by side, because we're not going to be working with both equations at the same time during substitution. We are going to use information from one equation and substitute it into the second equation. So if you take a look at step 1, step 1 asks us to write an equation containing only one variable and solve it. Okay. Well, I want to find an equation that is either solved for x or it's solved for y. And the nice thing about this first equation is that it is already solved for y in terms of x. It is already y equals. So because of that, step 1 is already done for us. What I like to do is take the expression that that variable is equal to and put a box around it. Now I recognize that y has the very same value as 2x. Y and 2x are equivalent. If a teacher is gone, a substitute will come in and replace the teacher for a day. That's exactly what we're going to do in the second equation. We are going to replace y with what it is equivalent to. From the first equation, we know that y is equal to 2x. So we are going to replace y with 2x. Okay. Then we solve this equation. Now we're going to solve this equation. 7x minus 2x is 5x. So I know that 5x is equal to 15. So to be able to solve this equation, I simply need to divide each side by 5. And I have solved for my first variable. And I know that x is equal to 3. So because I know that my solution is an ordered pair, I know that I only have half of the solution. So I need to solve for the second variable. I could go back and use either equation, but I'm going to go back to the simpler equation, the one that I had boxed. Y equals 2 times x. Now I know that the value of x is 3, so y equals 2 times 3, or 6. When I write my solution, I will write provided as an ordered pair, 3, 6. Now, just like yesterday, it would be wise to make sure that this ordered pair is true for both solutions, 3, 6. I'm going to go back to the equation 7x minus y equals 15 and just check, just to make sure that it works in the second equation. I've already checked it with the first equation. So 7 times 3 minus 6 should be equal to 15. 7 times 3 is 21. 21 minus 6 is equal to 15. So I know that this is a correct solution. And there is my solution. It's a solution, not solve. There we go. Solution. Okay, let's look at a second example. Okay, solve using substitution, and the equations are y equals negative 4x plus 8 and y equals x plus 7. Okay, again, I need to make sure that I take one equation and solve it for either x or y, which has already been done. This first equation is solved for y. In fact, so is the other one. Okay, I just chose this, okay, because it was on the left and I saw it first. So what I'm going to do is move away from this equation that I've placed the box around, and I am going to go to the second equation and replace y with the expression that it's equal to negative 4x plus 8. Now I'm going to have to do some work to solve this equation. So I'm going to have to add 5x, or excuse me, add 4x to each side. Okay, so that's going to give me 8 equals 5x plus 7. I'm going to subtract 7 from each side. So 5x equals 1. When we solve for 5, or for x, we need to divide each side by 5. So our answer is x equals 1/5, or as a decimal, that is 0.2. So we now have half of my solution. I know that x is equal to 0.2. Okay, I'm going to work from one of the two equations again. It does not matter which one. Now solve for the other variable. Since I know that x is equal to 0.2, I'm now able to solve for y. So y is equal to negative 4 times 0.2 plus 8 at this point. Of course, you can use a calculator if you need. Okay. All right, so negative 4 times 0.2 plus 8 is 7.2. All right, so our solution, the solution to this system is 0.2, 7.2. Think about if we had graphed this if we had solved this by graphing, it would be a little tricky because it would be very difficult to know that it was at precisely 0.2. It's hard to distinguish 0.2 from 0.3. All right, our last example for the day, okay, is the system y equals 2x plus 2 and y equals negative 3x plus 4. Again, as I'm looking at the two equations, they're actually both already solved for y. It doesn't matter which one I choose. I'm just going to choose the first one, and I am going to place a box around 2x plus 2 because I know that it's equivalent to y. Then I'm going to move to the second equation, to the other equation, and I am going to substitute in for y the expression 2x plus 2. And then, now I notice that I have my equation. It only has one variable, so I'm going to solve for x. So 5x plus 2 equals 4. Now I'm going to subtract 2 from each side. That leaves me 5x equals 2. And never leave myself enough space. Divide each side by 5. So x is equal to 2/5, and as a decimal, that is 0.4. So I have my first equation, x is equal to 0.4. I am going to use the first equation, y equals 2x plus 2. And I know that x is equal to 0.4, so y is equal to 2 times 0.4 plus 2. All right, so 2 times 0.4 is 0.8, and 0.8 plus 2 is 2.8. All right, so the solution needs to be written as an ordered pair. And the solution is 0.4, 2.8. And again, I could check that with the second equation just to ensure that it is correct. And it is. Okay, so my question to you to think about is, why is it sometimes easier to solve equations using substitution rather than graphing? And I want you to write your answer to this question in your notes. Once you have written this explanation, I want you to show me your notes, and you can go ahead and get started on the homework in class. Have a great day.